Welcome to Miss Taylor's class notes, and today our focus is going to be on reflections. So reflection is a transformation that uses a line like a mirror to reflect it. The mirror line is called our line of reflection, and reflections are rigid transformations, which means our shapes are congruent. Again, triangle DEF, when reflected over M, is congruent to triangle D prime, E prime, and F prime. And so we're going to talk about just some basic reflections first, which are just horizontal and vertical lines, just kind of talk about how those reflections happen. So for both of these examples, we're going to use triangle ABC. So I'm going to actually graph it first. 1, 2, 3. Graph it on both just to make things easier. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. 2, 1, 2, 1. So we have A, B, C, A, B, C, and then we connect our dots. So this first one wants us to reflect it over x equals 3. If it's x equals, it's a vertical line. And so we're going to go 1, 2, 3. And so x equals 3 is this line right here. And the other one wants us to reflect it over y equals 1, which is a horizontal line, which means our reflection is going to happen here. So for a reflection, they're going to be mirrored, or they're going to be the same number of points away from the line. So what I noticed about A is 2 points from the line. So A prime is going to be 2 points away on the other side. C is 1 away, so C prime is going to be 1 away on the other side. B is 2 away, so it's simply going to be 2 away on the other side. And so that is A, B, C prime. They are still congruent. It's just reflected over the line x equals 3. A prime is going to be 2, 3. B prime is going to be 1, 2. And then C prime is 4, 1. So now we're going to look at reflecting it over y equals 1. If it's on the line, it's simply going to stay on the line because it's not going to move. That's going to be in A's spot. It's just there because it's on the line of reflection. It has nowhere to go. So A is 2 away, so 1, 2 is going to give me A prime. B is 1 away, so 1 away is going to be B prime. And so that is triangle ABC prime. Our coordinates for A prime is 1, -2. B prime is 5, 0. And then, of course, C prime did not change since it was on the line of reflection. All right, so now we've got some official rules that we can kind of use and that we know are always true. Again, we're going to use triangle JKL for both examples. So J is 1, 2, 3. K is 4, 4. And then we're 3, 1. So 1, 3, 4, 4, and 3, 1. So J, K, L, and J, K, L. So our rule for the x-axis is we simply make the y value negative. So if we're going to reflect it across the x-axis, and I know that J is 1, 3, J prime is simply going to become 1, -3. And so we're going to graph 1, 1, 2, 3 for J prime. And if we notice, it's 3 away and it's 3 away. K is 4, 4, so it's just going to become 4, -4. Again, we just make, I know your note should say X and Y. These say A and B. I forgot to go back and change them. That's on me. But we're just adding a negative to our Y term. So 1, 2, 3, 4, that's K prime. And then L prime is going to be 3, -1. And for the x and y axis, we could graph them like we did the horizontal or vertical lines, or you can use the rule that we're given. So our y-axis rule is the opposite of the x-axis rule. We're simply going to make our x value negative. So j prime becomes negative 1, 3. K prime becomes negative 4, 4. And L prime becomes negative 3, 1. Negative 1, 3. And again, we're reflecting across the y-axis. 1, 2, 3, 4. And then 1, 2, 3. So that's j prime, K prime, and L prime. All right, so the other types of lines that we have is we have y equals x and y equals negative x. So y equals x is simply our perfect diagonal line. It's got a slope of 1, a y-intercept of 0. And y equals negative x, it's a reflection of y equals x. It's got a slope of negative 1, and its y-intercept is 0. So when we use these, we use our reflection for y equals x. We're simply going to flip the x and y terms. For y equals negative x, we're going to flip them and add a negative. So let's graph our original, or our image, our pre-image, which is FG. So negative 1, 2, and 1, 2. So this is F, this is G, and it's a line segment. So if it's reflected over y equals x, we just need to flip the x and y axis. So if f prime is negative 1, if f is negative 1, 2, then f prime is going to be 2, negative 1. So 1, 2, negative 1. That's going to be f prime. G prime is simply going to be 2, 1. And that's going to be G prime. And they should still be roughly the same distance away from each other. So if we did kind of like a slope down 2 over 1, 2, 1. Yeah. And so that's just kind of an easy way for us to tell that, yes, we did it correctly. So now let's graph the same FG. Negative 1, 2 is F. 1, 2 is G. And so if we're reflecting it over the negative, we're going to flip the numbers and add a negative. So f prime is negative 2, and since 1 is already negative, it's going to become positive. So negative 2, 1. And then for G prime, we're going to flip them and add a negative. Negative 2, negative 1. So f prime, G prime. And again, they should be the same distance away across the line of reflection. And so when we talked about translations, we talked about composite translations. Here we're going to talk about guide reflections. Guide reflection is a translation, then it is a reflection. So first we're going to translate it, then we're going to reflect it based on the rules we're given. So we're going to start with a triangle ABC, 1, 2, 3, 1, 2, 2, 3, 4, 5, 6, 1, 2, 3, and then 7, 1. So A, B, C. So the first thing we do is we're going to translate it. So x minus 12, and if we just see y by itself, nothing changes. So we're just going to move it to the left 12 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's A prime. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's B prime. And then that's C prime. And now they want us to reflect it over the x-axis. If we reflect it over the x-axis, the y value becomes negative. Or we can just remember that they're the same distance away, and so that's A double prime. That's B double prime, and there's C double prime. And so our coordinates for A double prime is -9, -2. B double prime is -6, -3, and then C double prime is -5, -1. And so those are our glide transformations. All right, so I want you to do this one on your own. Do your translation first, then reflect it over the y-axis. Remember that if we reflect over the y-axis, our x value becomes negative. So when we talk about reflections, we talk about line of symmetry, and which shapes have symmetry, how many lines of symmetry they have, and what does it look like. So a figure in a plane has line symmetry when the figure can be mapped onto itself. So that means when we reflect it, it looks the same off of a reflection of a line. This line of reflection is your line of symmetry. Shapes can have more than one line of symmetry. So if we're looking at this first shape right here, I know that if I divide it right here, if I reflect it there, that these points line up, these points line up, and so that is one of my lines of symmetry. I also know if I pick perfectly down the middle, those points are going to line up, those points are going to line up, and those points are going to line up. So this figure has 2 lines of symmetry. If we look at our hexagon right here, so I can divide my hexagon through there, and I know it's going to be the same. I can divide it there, and I know that those are going to map onto each other, and I can divide it here, and those will map onto each other. But if I also look closer, I see that if I did it this way, everything would map onto itself. If I reflected it this way, everything would map onto itself, and that way, everything would map onto itself. So this one has 6 lines of symmetry. If we look at this shape here, if I do it this way, those are going to map, and those are going to map, and everything's going to be fine. But I believe that's the only way, so this one has 1 line of symmetry. Words and shapes and things can also have lines of symmetry. This one right here, we could divide it here. It wouldn't, or does it? There, we would map the O's onto each other, but the L and K wouldn't map onto each other either. But this is just kind of an example to show you that it's not just shapes. You can also do it with words and other things and look at lines of symmetry. To me, this one would have 0 lines because the L and the K do not perfectly map onto each other. And so those are our reflection and our lines of symmetry.